So let's look at what happens when we do less than a year for the interest rate. And then we're going to assume we do that consistently. So what do I mean by that? So I'm going to take this annual compound interest formula and I'm going to tweak it to see what happens if we do monthly compounding. So again, we have this annual compound interest formula. And it says A, your future amount, is going to be based on your present amount times the sum of 100% in your interest to the power t. And here, remember, t is years. That's important. R is the APR, which means annual percentage rate. Now, if we work with an annual percentage rate, then we count with years. And earlier I had mentioned if it's a monthly percentage rate, then we should count with months. So it turns out we can do a monthly version of this, but the bottom line is in banking, they generally work with annual percentage rates. So if we wanted to do this monthly instead, then we have to prorate the rate by the amount of time that's gone by. Well, a month is 1/12 of a year. So what that means is the monthly rate will be equal to the yearly rate times 1/12. And if we think about fraction stuff, r over 1 times 1 over 12 gives me r over 12, right? Which basically the second part of this assignment said that in a slightly different way than I did. So if they give me an APR, but they're going to work with me monthly, then we have to prorate that, and the new monthly rate is r over 12. Okay, so how does our formula change? Well, instead of an r here, I'm going to have an r over 12. So for monthly compounding, my formula is going to look like A equals P times parentheses 1 plus my new monthly rate, which is R over 12, assuming R was an APR, annual percentage rate. Okay, now here I got to pause for a second because this says the power should be years, but I want the power to be months. How many months are in a year? Well, there's 12 months in a year, okay? So to change T years into months, I would just go 12T because there's 12 months in a year, right? Think about it. If 1 year went by, 1 times 12 is 12. If 2 years go by, 2 times 12 is 24. That's 24 months. So this calculates the number of months. Okay, so T is still years. We're going to stick with that. And if I want this to be months, then I would do 12 months up there. And there's nothing special about months. If you have a credit card, they work off your average daily balance and they use a daily percentage rate. Oh my gosh. Okay, we're going to take this a step farther. So again, write this down if you didn't already. For monthly compounding, the formula gets tweaked a little bit where we have our prorated rate, right? 12 months in a year. And then to count by months, but including years, it's 12 times the number of years. That counts the number of months up there. So we get a smaller interest amount more often. Is that better? Turns out it is a little better. We'll see that in a moment. We can go with daily though. Check it out. This is so cool. Daily compounding . Okay, so let's see. For daily compounding, I just need to know that there's 365 days in a year, kind of, sort of. So that APR, annual percentage rate, is R. What's the daily percentage rate? The daily rate would just be R split into 365 little chunks. So what's my formula look like? Well, it's going to be A, the future amount, is whatever we start with, times 1 plus my rate. And my rate, this is my new daily rate, R over 365. Now, the power has still got to be days, but we have to depend on years. And so if somebody says, okay, 2 years went by, how many days is that? I would just take 2 times 365. So to count the number of days, we just take 365 times the number of years that have gone by. Right? Notice that's pretty darn similar to the monthly formula. I just replaced 12 with 365 here and here. Now this is important. The 365 and the t have to be in the power together. Some calculators need parentheses for that, some don't. Depends on your calculator. My Google calculator needs parentheses up there. My Desmos calculator doesn't. My stupid calculator on my iPhone needs the parentheses, right? My Android tablet does not for its calculator. Right? It just kind of depends on the calculator. All right, let's apply this stuff. So again, we got some new versions of the formula now. We have a daily version of the formula where we tweak the rate and tweak the time, right? Cut it into daily chunks, find out how many days are in a year or many years. The monthly formula, take that rate, cut it into 12 chunks because there's 12 months in a year. Power, how many months have gone by based on a given number of years. Or just the simple annual formula, which looks so nice and clean now compared to the others. But that's what we got. Okay, so here we're asked to do a couple of things. If we start with the APR, annual rate of 2.4%, we want to know how much it would be per month. And we just divide by 12. So we'll do that in a couple of different ways. Now notice here, they're holding the percent sign off to the side. So we just want to know, okay, what's 2.4 divided by 12? That's not too bad. Calculator, 2.4 divided by 12 gives me a rate of 0.2%. Ooh, wait a minute, let's think about that for a second. This is often a weird idea. Let's go to a new page. Think about that 2.4%. That was the APR. We want an MPR, a monthly percentage rate. So we take that 2.4% and we divide it by 12. And then on my calculator, I just cleaned up that part right there. So what did that look like? Well, the calculator said 2.4 over 12 is 0.2. The percent symbol is still there, right? I haven't dealt with that yet. What does percent mean? Well, percent means divide by 100. So if I take 0.02, divide by 100, shift the decimal point twice, that means I need a couple more zeros and then the 2. So this is 2 thousandths, right? 2/10, 100 divided by, I can't say that right. 2/10 divided by 100 is 2 thousandths. Okay, 0.2% as a decimal. And for some interest rates, I don't even bother doing this division. We'll see that in a minute. All right, what do we got here? So we've got our new 0.2%, and we know how to write it as a decimal. And then we're asked to start making some calculations. So what's happening after 1 month, 2 months, 6 months, 12 months, 24 months, or 3 years? Okay. Now, I summarized that in that one equation, so let's just see how to apply the equation. And I'm going to get a screenshot of this so I can better fill it out. And again, this would be a good place for a spreadsheet. All right, so we want to use our work from the previous part of the lesson to complete this table here. And add that to a new page, please. Now, I've already summarized the formula for you, so I kind of cheated and snuck to the end, but I wanted to do that because I thought it just made sense to do it there. So this is for monthly compounding. Assuming we started with an annual percentage rate, that's important. So we take our principal times parentheses 1 plus 1 plus that rate split into 12 parts, because that's only fair, right? There's 12 months in a year. And then the power has to count by months. So that would be 12t. Okay, so again, t is years, but 12t counts months. And we'll see that in just a sec more clearly. So for this problem right here, I was given R is 2.4%. And I forgot what the amount was, though. I think it was $1,000 still. Yep, up here, starting with $1,000. So for example, for 1 month, that would be A equals $1,000 on my calculator, parentheses, 1 plus, now we could either do the reduced rate we already have, or we could write it up like 2.4, well, let's write it, we gotta have it as a decimal, don't we? Careful, what's 2.4 as a percentage, as a decimal? 2.4% means 2.4 over 100, shift the decimal twice. Okay, notice the 2 is in the hundredths position, 2% and a little more. And I can enter it into my calculator like that. I'll show you a couple versions of this. And how many months have gone by? Just 1 month. Okay, that's important, that this power counts the number of months. Now, this cleans up a little bit though, because didn't we just figure out on the calculator that the decimal version of the monthly rate was 0.002? And I can easily add 1 to that. That would give me 1.002. So it turns out this formula does clean up a bit. For this case, I could write it as 1,000 times 1.002 to however many months went by, which sometimes I need to think about as 12 times the number of years there. Okay, so I'm going to test out a couple of different things here on my calculator before we move on and fill out the rest of the table. All right, so my claim is I could type it that way the formula first appeared, which was 1,000 times parentheses 1 plus the fraction where I put the decimal of 2.4%, 0.024, and then divide by 12 right there, and then raise it to how much time went by. And here's saying 1 month went by. So then I should have $1,002. Now I cleaned this formula up a bit because this fraction turned out to be a nice decimal. They don't always work that way. 1,000 times 1.002 to the power 1 doesn't change anything. Notice I get the same amount there. Now, you might, I don't know if anyone's having this confusion here. Here I said to use 12t, but here I just put in a 1. Right? So why did I do that? The 12t counts months. That's one reason why. So if that makes sense to you, then move on and ignore me. If it doesn't make sense to you, then let's think about the period here. The formulas for compound interest, t is supposed to be the number of years that have gone by. But this column right here says months, 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 months. Oh, all of a sudden it says years there. That was sneaky. So if I compare months to years in a different table here, 1 month is 1/12 of a year. So if I think about that with my 12t, where t is supposed to be in years, what happens if I take 12t, I say t is 1/12. What's 1/12 times 12? Well, it's 1, that 1 month that just went by. Okay. So sometimes when I'm using this formula, if I'm thinking in years, I plug in the number of years. But if I'm thinking in months, I just say, hey, this many months went by. No big whoop. All right. So I'm going to leave you guys right now to try and fill in this table using the formula that we've developed here. And you could use this version, cleaned up one, or you could use it based on this other version up here. Now keep in mind, the other version up here, it's expecting T to be years. That's super important. I got to distinguish that. Got to read the fine print, use the right units. It's like we can't mix minutes and hours. We can't mix months and years unless we're clever about it, careful about it.